Oh, hello again. I'm back and back in the basement. This is a follow-up to my last video. I've seen quite a few YouTube posts about airplanes crashing, also on Facebook, and some of the model airplane groups I follow there too. And it seems like there's, at least to me, a lot of folks out there that don't understand how these receivers, whether it's Spectrum, and my stuff's all Spectrum, but there's Reflex and FMS and other gyroscope systems out there as well. How these work and what they do, and how, if not programmed correctly, these receivers will cause your airplane to crash. So let's start off with talking about the electronic gyroscopes in these things. And I'm going to include a link to a paper from AMA that explains how these things, basics of them, how they work. Years ago, when I started learning how to fly, gyroscopes in airplanes were mechanical and were powered by air, not by air pressure, but by air vacuum, because you want air to be going through those gyroscopes, not in the direction that it flows out of the pump, but where it's sucking from. Because if you put it on the pressure side and the pump blows up and a vane comes off, then that vane is going to go into the gyroscope mechanism and potentially ruin the gyroscope as well. So we had, in the airplane, we had a vacuum gauge that had to be somewhere around 3 to 5 inches of vacuum for the gyroscopes to work right. And there were actually 3 gyroscopes in the airplane. There was an artificial horizon, which is basically pitch and roll. There was a gyroscopic compass that had to be set to the magnetic compass manually, and an electric gyroscope on the turning bank indicator. And that one was the kind of the backup for the vacuum system roll axis on the airplane. Nowadays, in 2024, there are ways to do away with all of that mechanical stuff. And it's the same technology we find in these receivers. Now, tiny little electronic gyroscopes. Very, very dependable as long as they get power. Uh, very accurate. They are shock resistant. They're not particularly temperature sensitive. And they don't have a mechanical pump that powers them. That refers to the artificial horizon and gyro compass. And I've had those fail. I've had the gyroscopes fail. I've had the vacuum pump fail numerous times in 57 years of flying. Fortunately, none of that was in instrument conditions. But nonetheless, nowadays we have electric gyroscopes powered off the aircraft electrical system and standby systems powered off of self-contained gyroscopic indicators, gyroscopic heading, gyroscopic attitude indicators that operate totally independently of the aircraft electrical system, and that's our backup. And we also, of course, have iPads for navigation. Those are totally independent of the electrical system. We have a lot of backups we didn't have 57 years ago, which is really, really nice. But nonetheless, this technology, among the first uses it had, was in radio-controlled airplanes for gyroscopic stabilization. Back 30 years ago, we had roll, pitch, yaw, and power, 4-channel radios. That was it. And now you look at these modern transmitters and receivers. Oh my gosh, this one's got plug on it. You can plug GPS into it. You can plug in a remote receiver. I don't know what else. Those are the two that I'm familiar with. They work off of the port here. And those of you that are real experts in this probably know of a lot of other things you can plug into these receivers to add to their capabilities. But nonetheless, let's talk about the three modes that these receivers enable via programming off of the transmitter. So I'm going to go get my crescendo and put it together, and we're going to take a look at how this works. Again, this is not for you guys that have been doing this for years. This is for beginners. So let's go look at that crescendo's control surfaces. It's a fairly small airplane, and it has the AR637TA in it, just like this one. It still has the missing antenna. I just found them on the internet and ordered some set of 4 antennas that off of Amazon that are specifically for this radio. And it should be here by Friday, and I'll take the 4 screws off the back, split the case, and put the new antenna in. So let's go get the crescendo. Okay, here I have the crescendo and my NX8 transmitter, and we're going to go through a few steps with setting this up. Remember when we had this AR637TA, this one here, we had reset it. And if this one had been reset, we would also need to go through some of these steps. So the first thing we're going to go through is orientation. With this airplane, that's particularly important because the receiver is mounted here in the tummy, and it's upside down from the way you would normally mount it on the floor of the airplane. On the deck here, this way up. This one's mounted this way, and that way is up. Sort of up anyway. It's upside down. And if you don't do the orientation right, you're going to wind up with elevators that are reversed for the gyroscopes. So I will illustrate that by going to forward programming. Gyro settings. Nope, wait a minute. Yeah, system setup. Orientation. Right here. So set the model level and press continue. Continue. Set the model on its nose and press continue. Orientation 3, that is correct. It shows me on the picture on here, shows me the receiver turned upside down and the leads pointing this way, back toward the tail. That is the correct orientation. Go back, go back. I'm going to go all the way back to the home page, right there. Now I've got it in safe, and I'm going to check. Yes, those ailerons are reacting correctly. That is trying to push nose back up. That's trying to, the wings back up. That's correct. And I can see that the elevator, when I point the airplane down, the elevator is trying to raise the nose. When I point the airplane up, the elevator is trying to lower the nose. And I don't have any rudder correction on this model for the gyros. So that's the first step you're going to take. Now, the next step you're going to take is check to see, and this would have actually probably revealed that, but check to see if any of the control surfaces are not working properly. So this should give me a left turn. Yep. This should be a right turn. Elevator up, elevator down, left rudder, right rudder. Okay, everything is correct. But what I'm going to do is go into the menus and go to Servo Setup, click Travel, and go to Reverse. And I'm going to reverse the elevator servos. When I did that, now when I pull up, the elevator goes down, and down and up is down. That is supposed to be down elevator, and you can see that it's actually going up. So that's not right. But if it was right, let's assume for a minute that this was the correct servo settings for this airplane reversed. Then I'm going to go back and fix that. It's up, down. Okay, so I fixed that. But I have had models where when I put them all together and hooked up everything, for one reason or another, something was reversed. So let's go through, and I'll go get the camera and we'll show you how to relearn servos. Here we are on the home page. Now if I needed to relearn servos, and this applies to any of them, what I would do is go to Forward Programming, Other Settings. Oops, wait a minute, wrong. Gyro Settings, System Setup, Relearn Servo Settings. Click on that. And if I had reversed a servo, that will correct that when I go to set up safe. Okay, the next thing we're going to do is reset Failsafe, because that also got erased when we reset the receiver. To do that, we're going to go back to Forward Programming, go to gyro settings. Nope, don't do this very often. Other settings. Oh, here we go now. Failsafe. Okay, I'm going to set it manually. And this model is a little different in that I've got separate channels for left and right ailerons. So that will make a slight difference in the way we have to set this up. Okay, I'm going to set up Failsafe on AUX4 because I've got nothing else on AUX4. AUX2 and 3 are often assigned to other functions, but in this case, we're going to use AUX4 for this. Okay, so having said that, and that is, by the way, AUX4 is a preset for everything. Don't need to set a position. So I'm going to back out of that, go back to Failsafe, and we're going to go to way to the start here, if I can get it. Throttle is preset to minus 100%. So if I go into Failsafe, that shuts the motor off. Right aileron is 15%. Normally, if I set one aileron to a positive number, I'll set, whatever I do, I'll set one aileron positive, one aileron negative to the same percentage. But in this case, because we have two different aileron channels, they have to be set to the same value, not one of them the negative of the other. So we'll go to elevator. It's 6%. That gives me 6% up elevator. And rudder 0. Gear not assigned. Left aileron 15%. So this will actually set up about 10-degree right bank descending with the motor off. And it will hold that until it hits the ground. So Failsafe is now set. So the next thing we're going to do is set up our AS3X Gains. And I use fixed gains, and my gains are only needed or required for the B switch in the up position. The other two positions have AS3X turned off. One is manual mode or no gyros, and the other one is safe mode, which does not require AS3X. So AS3X gains are set to roll, pitch, and yaw 40, 50, 60. These are defaults for the crescendo. If you have a jet like my L39 over there, you're going to want to reduce those significantly. I think it's set at something like 15, 30, and 40 for roll, pitch, and yaw. And the reason is the faster the airplane and the higher the wing loading, the less sensitivity you need. I think I got that right. Anyway, probably ought to check with the manual and see where these need to be set. If you take an airplane up and it starts to oscillate in roll, pitch, or yaw, you need to reduce speed, bring it back, and reduce these gains. Okay, I have gain sensitivity set to 1x. I can do adjustable gains and assign these gains to the rotating knob, right knob, whatever you call it, or a switch, or I can set them to one of the trim switches, left or right trim, up at the top. Heading, I don't need that in flight mode 3, so we don't really need to change these gains. Okay, so let's go set up AS3X and Safe. To do this, we need a switch, obviously, to change modes, and that switch needs to be assigned to a transmitter receiver channel so that we can channel those inputs into actions that the receiver is going to perform. So to do that, we're going to need to go to System Setup, yes, and down here to Channel Assign. And this would be a good time to talk about ports, channels, and switches. The 6 channel so-called channels of any receiver, but the Spectrums in particular, look like this. But notice there's actually 8, and actually there's more than 8. So 1 through 6 are channels that are assigned to throttle, aileron, elevator, rudder, gear, and AUX1, which is normally used for flaps. In this model, gear is assigned to A, but since the crescendo doesn't have any landing gear, that is kind of meaningless. 6 is assigned to flaps normally, but we're not even assigning it there because we're using flaperons, which is a totally different setup. There's a video on that on my site. AUX2 is inhibited, and note that AUX3 is assigned to switch B, the upper left front of the NX8. Why switch B? Well, that was what my first E-flite model was assigned to, switch B, for flight mode selection, and I've just kept it on switch B ever since. I got used to it. It's just, well, let's see, right up here, and it's very handy. I like it there. It's kind of out of the way, and I'm used to it. But you can use any switch you want as long as it's a 3-position switch for what we're going to do. So if you want to change that switch setting, you're just going to go over here and select that and move it to A or B or C or whatever. But it has to be a 3-position switch. A won't work. And he's already assigned a gear here. You'd have to change that too. Anyway, make sure that each switch is assigned to a unique channel. Now, ports are something else entirely. The AR637 and all the Spectrum 6 channel radios actually have 7 ports. The port 0, which is the programming port before port 1, but we're not using that today. We did use it to reset or to reprogram the AR637TA. Okay, so this is set up. Now we're going to go to flight mode setup and assign switch B with 3 flight modes. If I change this, switch A, but I want switch B with its 3 positions to be a flight mode. Okay? Now, once we do this, we're ready to go to the next step, which is going to be setting up the gyros for AS3X on, but safe off, safe on without AS3X. Optionally, you can enable it, but my experience is it doesn't matter. Safe does everything AS3X needs, or it does, including flight stabilization, but you can enable it if you want to. And the gyros off. That is 0 input from the gyros to the aircraft control surfaces. You're in manual mode just like you would have been 20 or 30 years ago without these gyros. And as I'll point out later, that can be very, very useful. So next up, flight mode setup. This is the key. Okay, in flight mode 3, which is the B switch up, flight mode channel, and AS flight mode channel is, I can't remember, let's see, oh, never mind. There, is set to AUX3. There we go. Back. Oh, go to next. Now it comes back here. AUX3 and AS3X is set to active. I'll flip the switch to mid, flight mode 2. Flight mode channel is still AUX3. Yep. And everything is turned off. If I go to flight mode 1, safe mode is set to self-level angle. I can set that to envelope or inhibit. That's where it needs to be though. So we are all set up now in safe. AS3X gains are set, orientation is set, and flight modes are set to AUX3 and switch B. Okay, now there are a couple of other settings we need to take a look at. When we get to safe settings, let's go back one level and go to safe settings. In forward programming still, safe gains, flight mode 1, that's safe, roll and pitch set to 35. Flight mode 2 and flight mode 3 are not applicable. This is only for safe mode. Okay, go back here, angle limits. I have max angle limits, roll left and right, pitch up, pitch down, set pretty wide. And by the way, these are also affected by the rates you set in rates in Expo. So if I go to low rates, I won't get the full 60 degrees bank or 40 and pitch up, pitch down elevator. I set pitch up pretty high so that when I have 3S battery in here, I can climb at 75 degrees, which is darn near vertical, if I'm in safe. Of course, if I'm not in safe, there's no limits on it. Okay, so here is where you set the maximum bank. If you have an airplane that you put in safe and on high rates and it's not turning fast enough, this is where you would come to increase the maximum roll rate so that you can make a tighter radius turn. And then one more step, that you've reset your receiver, go back in here and go to Telemetry, since that is also has something to do with the receiver, and do an auto config just to make sure that all your sensors are still working after you've reset. Yes, we have smart battery, G-force, gyroscope, variometer, altitude, smart ESC, GPS, everything that's in there is still working. Okay. Go back and back. Now, what don't you have to set? These things are programmed into the transmitter. There we go again. I don't have the battery charged, that's why that keeps popping up. Servo setup, rates and expo, differential, throttle cut, throttle curve, switch setups. I don't know what 3-axis gyro actually does. The flap system, mixing. You may want to rerun your range test, but if it was working before, it should be working again. Your timer, audio events, if you have these set for switch changes, those should still be there just fine. Function bar, of course you've already done bind. And none of these system setup items should have been required, unless you're setting up a new model, in which case you're going to go here first and set up all of this prior to going into forward programming and playing around with the receiver settings. Okay, so in the prior video, we reset the AR637TA. In this video, I've gone through the rudimentary settings that you need to reprogram the transmitter and the receiver together so that they do what you expect it to do. And I can't emphasize this too much. When you get done with this, before you take the airplane back out to the field, you need to take a good hard look at how everything is working. Make sure that your safe select switch is working correctly, that AS3X is working. Once you power it up and pulse that throttle up and down and shake that model and those controls are moving. If safe is working correctly, AS3X will work correctly, except maybe you might need to adjust the gains a little bit. If the gains are too low, you won't even know it. The gains are too high, the model may be oscillating at speed and you need to reduce those gains because the AS3X system is over-correcting for turbulence. One thing that I have done is turn the gyros off for the first flight after a receiver reset, take it up to altitude, and then turn safe on and see if it really is working right. If it's not, turn it right back off, come back and land and reprogram it if you need it. Now, realize that not all people think they even need AS3X or safe, and that's fine. But if you're going to use them, you have to learn how to program them correctly, or it's going to cost you a lot of time and money to correct your errors. Trust me, I know. Thanks for watching. If you like this, think about subscribing, give me a thumbs up, or a comment if you have any questions. I love to answer questions. I really, really do. And I try to answer them all within a few days. I don't pretend I get them done same day. So anyway, hope you're having a great summer. We're about halfway through the flying season now around here in Indiana, and it's been quite rainy here, but Friday's supposed to be a great day, and then I'm taking off to Canada for a week. So anyway, thanks again for watching. I so much appreciate it.